Hello, in this video we're going to cover the combined cycles. In our first video we covered the Rankine cycle where we take the fluid with our pump, send to a boiler, the turbine or expander, then take that fluid, put in the condenser to turn into liquid form, feed it again to the pump. But we said that in this cycle we reject heat at the condenser. And one use of this heat was in a regenerator to preheat the air here, so we save from the Q in we need to offer to the boiler. Another use of this heat going to the condenser is to use it as the boiler, as a heat addition heat to a second cycle. So instead of having the condenser here, we pass the fluid through a heat exchanger to condense it and use it in a Rankine cycle as before. Okay, but now we add another cycle parallel to the first one. So we have another pump pumping a different fluid of usually lower boiling temperature to the heat exchanger. So take the heat, change phase, send it to another turbine, send to another condenser, and then back to the second pump. So now we have two cycles. We know how to balance the energy in the heat exchanger, and we know how to solve each cycle separately. A special case of a combined cycle is a gas turbine cycle. So we have a gas turbine that will take air, as we saw in the Brayton cycle. Okay, the air will be compressed, passed in the combustor, increased in temperature, so heat addition here, and then expanded through a turbine. And now instead of throwing away the exhaust gases which have high temperature, we pass the exhaust gases to the heat exchanger and then release them in the atmosphere. And on the other side of the heat exchanger, we add water cycle, any Rankine cycle, which takes the heat from the heat exchanger to turn a turbine and then condense the liquid and then used again in the pump. So now we get more work. We get the work from the Rankine cycle and the work from the gas turbine. In some particular cases, because we still have to reject heat on the condenser of the second cycle, instead of throwing this heat in the environment, this heat is taken by a heat exchanger and sent to a heating application, maybe at a house or an industrial use of heat or any other use. So all these cycles, they do not increase the efficiency of each cycle individually, but the thermal efficiency of the whole plant. So the thermal efficiency of the whole plant is all the useful work we get divided by the heat we need to offer. So the overall thermal efficiency of the plant increases, but not of each cycle individually.